we will be developing tools and techniques to find areas of shapes with fairly complicated curved boundaries like the one shown here. To begin with, let's think of this problem. Let's see if we can approximate the area of this shaded region, where all we know about this function is the function value at these 4 places. We know the height at f of 3 halves, we know the height of f of 2, we know the height at f of 5 halves, and we know the height of f of 3. How can we just use this information to get some approximation of this blue shaded area? Well, the idea would be to draw rectangles, because we can find the area of rectangles. Rectangles are simple shapes, and we can find their area just by multiplying base times height. We could draw in 4 rectangles like I've shown here. In each case, we'll know the base, and we'll be able to figure out the height from what's given. And then we could say, well, the area of this blue shaded region here, that area is approximately equal to the sums of the areas of these rectangles. So we could say, well, we could find the area of A1, find the area of A2, find the area of A3, find the area of A4. Those are simple shapes, so we can find areas of each. Add them all up. That'll be approximately the area of this blue region. Of course, it's not exact. We overestimated here and included some stuff outside the region. We underestimated here and didn't include some stuff inside the region, and so on. But it'll at least be an approximation to the area that we want. So what we then need to do is we need to find the areas of each of these rectangles. To do that, let's mark the height and the width of each of the rectangles on the graph. The height of this rectangle is found by substituting 3 halves into the function, and so this height is actually f of 3 halves. The height of this rectangle is found by substituting 2 in the function to find this height, so this height is f of 2. The height of this rectangle is found by substituting 5 halves, so this is f of 5 halves. And finally, the height of this rectangle comes from taking 3, substituting it into the function, and getting this height, which is f of 3. So we can use those to find these areas. So for example, the area of this first rectangle is the width. The width is a half. 3 halves minus 1 is a half. The height is f of 3 halves. So the area of the rectangle is the width times the height, the half times f of 3 halves. Plus, let's find the area of the second rectangle. Again, the width is a half. The height this time is f of 2. So the area of that second rectangle, A2, is f of 2 times a half, half times f of 2. Similarly, the height of A3 is going to be a half times f of 5 halves, and the area of the rectangle A4 is going to be a half times f of 3. So now we can use this information that we're given and substitute it in these values and actually come up with a value to approximate the area. F of 3 halves is 37 over 32, f of 2 is 13 over 16, and so on. And now we get a fraction that we can simplify to get an approximation of the sum, or approximation of this area, which consists of the sum of these 4 rectangles. And so this simplifies to 69 over 32, which is 2.15625. That number right there is exactly the sum of the area of these 4 rectangles, and that's an approximation to the area of this blue shaded region. We can get better approximations by using more rectangles, and that's what we will do in future videos.